Hello everyone, good day. Welcome to Retalk South Korea webinar. Honored to have all the audience and the presenters here today. This is Dari, project producer of Green Energy Future South Korea 2020. Retalk South Korea is one of the Retalk series of online live webinar by leader associates to bring you more business content and project information about the South Korea wind and solar energy market. So far, this is our third version, aimed to complement the physical gathering of Energy Future South Korea 2020 and do what we can do to assess your business in this market. Today, we will talk about the ways to reduce wind project construction uncertainty in South Korea. Here is a brief agenda. The webinar will be an international one as our guest presenters are from 3 different countries. Mr. Guzman, Head of Business Development Offshore Asia from EGPR Engine JV, is now based in Spain. Mr. Andrew, APAC Business Development Manager, Wind Energy Applications from Peikko, is now based in Finland. And Mr. Hongjun, Senior Associate, Projects from Baker McKenzie, now based in Japan. With a passion and knowledge in wind energy construction, we gather together and we'll have a deep dive from offshore to onshore and to legal perspective. Every presenter's presentation will include a 20-minute speech session and a 10-minute Q&A section. Before we start, to engage in the webinar better and interact with our speakers better, I have a few items to remind in advance. First of all, sound. During the webinar, the audience microphone will be muted to avoid having background noises. If you can hear me clearly, you are doing well with the audio. But if at any time during the presentation you have sound troubles, you can switch over to a telephone mode. As you can see at the control panel, there is a chat box option. We have kept the dial in numbers inside, while the webinar and participant ID person by person. Please kindly check the email notification and call in with your own ID. Second of all, interactive Q&As. If you want to ask questions to our presenters, there is a Q&A box for usage. It's also in the control panel. And we will go through the questions at the end of each presentation. One important note is that please do not add further questions or comments once the Q&A session starts, as we hope to create a comfortable environment for presenters to address the pre-asked questions. As there might not be enough time for presenters to answer all the questions, they will also type to answer your questions after they finish their part. And last, recording sharing. Today's webinar recordings will be shared with all of you by email this Friday and will be posted on Green Energy Future South Korea website as well as social media channels. Okay, the last slide of my introduction is who we are and what we do. Leader Associates is an international clean energy event organizer and is one of the largest in Asia Pacific. We are going to host our offline Green Energy Future South Korea event in Seoul this November and would like to take this opportunity, stay connected with all community peers. Now, let's start from the housekeeping items and start with our first presenter of today, Ms. Guzman from EGPR and Engine JV. Ms. Guzman has 12 years of experience with EDPR in the renewable sector, dedicated to the development of different technologies around the globe. Ms. Guzman, could you please share your screen and start your presentation?
Yes, thank you. I will share my screen now. Thank you very much. First, I would like to introduce myself. I am Guzman Figar. I am the head of business development for Asia of Ocean Winds. Okay, I am also the project director of Korea Floating Wind. I am based in Madrid. I usually travel every month to Korea, naturally, until the quarantine started. I have been working remotely since February, like most of us have been doing. Okay, so thank you to everybody who is attending the video conference for your time and for your interest. And thank you also to Leader Associates for giving me the opportunity to present. It is a big honor for me to be here. Okay, what I would like to speak about, many of you have heard about the Windfloat Atlantic. It is a 25 megawatt floating project. We finished construction very recently. So the objective of today is very quickly present to you the Windfloat Atlantic project, explain what were the main challenges we faced during the construction of the project, and then try to identify the key learnings from Windfloat Atlantic that could help us in Korea floating wind or other floating offshore projects in Korea to become more effective. Okay, before I dive into the presentation, probably the name of Ocean Winds has been a surprise for everyone, and probably most of the people don't know about Ocean Wind. You probably know EDP Renewables and ENGIE. EDP Renewables and ENGIE, we have been working as partners in many projects throughout the world for many years. So in March 2019, we decided to take this partnership one step further, and instead of being partners project by project, be partners worldwide as one single company, in which both companies merge all our offshore teams and all our offshore projects. Okay, so this one company was formalized in March this year, but until yesterday, we had been referring to us as EDPR ENGIE JV. Okay, but of course we have a new name, we have a new brand, and a new company. The new company is called Ocean Winds. It is now only literally one day old. But of course we have very ambitious plans for South Korea, very ambitious plans for the rest of the world, and we hope you will hear a lot from us going forward. Okay. Then if we go back into the presentation, I think I need to be very fast because I only have 20 minutes. So I will like to explain to you what is the development cycle, or what is the work we have been doing over the last more than 10 years in floating, and how we believe to develop, and how we believe we can develop the capabilities necessary to construct a project like Korea Floating Wind, which is an extremely large and complex project. Okay. So we have been working in 3 phases with 3 projects. So the first objective was to prove that the technology works. Okay, so we did this with our first prototype for floating. It was the Windfloat prototype in Portugal. It was a small project of only 1 turbine of 2 megawatt. This project was constructed in 2011. We operated it for 5 years and we decommissioned it in 2016. Okay, so the objective here was to prove that the technology works, that a turbine can be put into the sea on floating platforms and can generate for a long period of time. Okay, this was achieved. So our next step in the process of learning was to prove that the technology is bankable. Okay, and for that, we built the Windfloat Atlantic project, which will be the main focus of our discussion today. It is what we call a pre-commercial project. Okay, it has larger size 3 turbines, which you can see in the picture, of 8.4 megawatt each. Okay, Mitsubishi Vestas turbines. And the construction of these 3 turbines was done throughout 2019 and 2020. The last turbine was put in operation last month in June 2020. In this project, we have been working with other partners, EDPR and ENGIE. Before we were one company, Repsol and PPI. Okay, this project, we finalized construction in 2020. So our next big challenge is Korea Floating Wind project. We have other floating projects throughout the world, but Korea Floating Wind is the one we consider our flagship project for floating. Okay, so Korea Floating Wind, we expect to start manufacturing in 2025. So we now have 5 years to make the transition from Windfloat Atlantic to Korea Floating Wind. Okay, here you have a graphic simulation of Korea Floating Wind. You can see, I don't know how well you can see it, but you can probably see a lot of white dots, and each of these white dots is a 15 megawatt turbine. Okay, so you can imagine the size of this. Okay, but in any case, so that you better understand, some of the facts from wind float Atlantic to Korea floating winds. I cannot go into the detail of all the facts, but we are going to transition from a 25 megawatt project to a 1500 megawatt project. From a project located fairly close to the coast at 100-meter water depths to a project that is very far from the coast in very deep waters. Okay, from a 3-turbine project to a 100-turbine project. The interconnection in wind float Atlantic was not within our scope. It was done by the transmission system operator, whereas the interconnection and electrical infrastructure for Korea floating wind will need to be done by ourselves. Naturally, a project of this size and so far away from the interconnection point requires very complex electrical infrastructure. In wind float Atlantic, we achieved project finance. That was one of the key ambitions. But of course, for Korea floating wind, we still don't know what the final capex will be, but it will be around overall $5,000 million. In order to obtain all this financing, you need many, many banks, both national and international. Okay, and the construction, our ambition today is to start in 2025. That gives us 5 years. We start manufacturing in 2025. Offshore installation will start somewhere around 2026, 2027, and the construction will go on for many years. Okay, we are still working with the yards to assess how many years it will take to produce the 100 floating platforms. Okay, but then after this, we are extremely proud of what was achieved in wind float Atlantic. We view it as one of the great successes of our company in the last year. Okay, however, the objective today is to talk about ways to reduce construction uncertainty in Korea. So for that purpose, I am not going to go deep into all the good things about wind float Atlantic, but I will focus mainly on 4 of the key challenges we faced. Okay, explain to you what the problem was and try to identify few actions that should be taken in order to be prepared for when Korea floating wind or other floating projects reach the construction stage in Korea. Okay, I will talk about 4 challenges. Okay, development of supply chain, manufacturing of foundations, offshore installation, and electrical infrastructure. Okay, so the first one is the development of the supply chain. You can see here, well, first, if we want floating offshore in Korea, we need local supply chain. It is impossible that these projects exist without a large local supply chain, not only because of the impossibility of doing these projects without local supply chain, also because the government has communicated very clearly that the localization and the job creation is a fundamental part of this industry. Okay, here you can see the supply chain of wind float Atlantic project. As you can see, there are many contractors. Many of them are well known within the industry. Okay, but the important thing here is to identify that most of the developers, when we start looking at the project timeline, we start looking at it from a permitting perspective. Which permits I need to identify when, but at the end, this is the most time-consuming phase. Okay, you need to spend several years developing all the agreements with all these people in order to be ready for a project to proceed to financial close and construction. And when I say several years, it means that probably projects will finalize the permitting before we finalize all the commercial agreements. Okay, and we will run into a situation whereas the project is ready to be constructed, but you are still in conversations to close all the commercial agreement, and that is what is delaying the project. That is a reality that happened to us. Okay, in Korea, it is going also to be extremely complex because there is no Korean industry supply chain for floating offshore industry. So we will either foreign players will need to set up operations in Korea, or Korean players will need to open a new line of business, okay? Both things require time, require investments, and requires commitments. So my recommendation here, or the key thing I see in order to not see the projects being delayed is start preparing early. Okay, what does start preparing early mean? Those of us who plan to build a project should start engaging with the supply chain as early as possible. Foreign companies that plan to participate in the Korean offshore industry need to start setting up national operations now. And Korean companies that plan to participate need to start developing the team, the capabilities, the relationships from now, okay? So we need to take action now. That's my main takeaway. The second point is the manufacturing of the foundations. These, you can see, are the foundations of Windfloat Atlantic. 2 foundations were constructed in Portugal, in Lisnave, 1 in Spain, in Navantia. Okay, this was a challenge because these shipyards have never constructed this type of foundations, first. Second, because this type of foundations had never been constructed anywhere. Okay, so a lot of improvements need to be introduced in terms of the design, okay, in terms of the processes, how to do it. Also, the shipyards need to be more comfortable and have a better understanding of the construction process. The first time you build something, you are less efficient than when it is the 10th or the 20th time that you build it. Okay, so in summary, because these were the first floating platforms that were constructed of this size and in these shipyards, we have several delays, okay, in the construction. We do believe this will improve as the technology matures, okay? More and more floating foundations will be built over the next years, so we will develop a more optimized design, better processes, more automatization, okay, of the processes, and we will be able to be more efficient in constructing these platforms. Naturally, we cannot just rely on the industry per se or the foundation manufacturing per se to become more efficient. We need to be very proactive in engaging with shipyards, with designers in making this happen, okay? So the main takeaway of this is optimization and automatization, okay? Try to industrialize the manufacturing of the foundations process, which right now is a more manual process. Okay. The third challenge I would like to identify is the offshore installation. Okay, this is the port of Ferrol in the north of Spain. It is 200 kilometers from the site, from the project site. So the turbines would be erected on the port and towed to the site, okay? What is the main complication on this? I think all of us who have been in the wind industry know how complex that the weather is the main risk during the construction. Of course, in floating, in this type of construction, the crane is on the earth and the turbine, the foundation is on the sea, okay? Which means that you need very, very calm weather in order to move ahead with the installation. As soon as there is movement, as soon as the sea moves, there is a relative movement between the platform and the turbine, and the erection cannot be done. Okay, as a result of this, the weather windows are very limited. Okay, and this is also complex because the installation is when a lot of the different work streams you have open in a project meet. Okay, the foundation needs to arrive to the port, the turbines need to arrive to the port, the cranes, the vessel, okay? And last, the infrastructure you need in order for the installation is very expensive, ports, cranes, etc. So if you have your infrastructure idle, you have a lot of standby cost. If you need to send it back because some of the turbines or some of the foundations are not ready, you have very high mob and demob costs. Okay, for us, as I was saying before, our plan in Windfloat Atlantic was to start the installation in spring, early spring 2019, in order to benefit from the weather window, from the summer weather window, which is the most optimal period of time for the installation. But there were delays, and all projects will see delays. There were delays in the interconnection. There were delays, as I said before, in the platforms. And at the end, we could only start the installation towards the end of the summer. Okay, this means that we had only a few months until the weather window closed, and we were, of the 3 turbines, we were only able to build 2 in the 2019 weather window. Okay, as a result, 2 of the turbines were put into the sea in 2019, but the 3rd turbine we had to wait until this year, until May this year, or late April, early May this year, when the good weather came again, and that's when we had to put the 3rd turbine in operation. Okay, so this is an extremely complex thing to manage. We still need to learn how we can, in projects of 30, 50, or 100 turbines, how we can do this. But in any case, we need to plan for this. We need to be aware of the overcost the weather windows will create, and make sure that we make full use of the weather windows. Okay, and the 4th part is the electrical infrastructure. I spoke before very quickly and very briefly of the complexities of the electrical infrastructure of Korea floating wind. But in any case, basically, if you don't have your electrical infrastructure ready, you cannot put the turbines to the sea. Well, you can put them, but 2 things will happen. You will have extremely expensive maintenance, okay, because having a turbine idle is extremely expensive, and it is also bad for the turbine, okay? So the electrical infrastructure is an extremely complex project, but if it is not ready, you cannot move ahead with the rest of the project. So this will be a challenge, and we need to plan accordingly and make sure this extremely complex interface is built accordingly. Okay, another challenge specifically for Korea floating wind and for the projects in Ulsan. I think most of you know about what is happening in Ulsan, but there are 5 extremely large projects being developed, okay, which could be up to 7,000 megawatt of projects. And then the grid integration for our projects is also going to be a challenge, and we need to work with KEPCO and with the Korean government to overcome this. Okay, then because if I needed to make a summary, it is very complex to explain to you how to reduce construction uncertainty, because floating offshore projects are extremely complex. But what I can say, if I could just provide an advice, is to start preparing now, because 4 or 5 years will go by very fast. Okay, and we will be in construction very soon. Okay, what does start preparing now? If you are a student or a professional, seek training. If you are in management, train your employees. If you're a company, try to obtain experience by becoming involved in other offshore projects in other parts of the world. Okay, I invite the shipyards to work alongside us in developing the processes and the automatization required in order to be more effective in the manufacturing of the foundations. Okay, companies need to start developing relationships with other offshore international players, or with other Korean players if you're an international company. Okay, seek partners that have complementary capabilities to you. Okay, so there's a lot of things we can do to prepare, okay, in advance of the industry. And naturally, health and safety, that is critical. A negative health and safety record could be very damaging for any project and even for the entire industry. So we need to start developing and implementing the necessary health and safety standards. Okay, this is a lot of work, naturally, but because I'm encouraging you to do this, I would like more or less to share with you our view, okay? Which is the Korean government communicated recently a target of 70.8 gigawatt of offshore, okay? All of us have different ratios. Using a conservative ratio, we're talking about a $50 billion industry from now to 2030 only in Korea, okay? So that's the first thing. The second thing, the Korean program is now the more advanced program for floating in the Pacific. Okay, many other countries are already setting up offshore programs like Japan or like the United States. What does this mean? That for Korea, this is there exists the possibility not only of becoming the floating offshore hub for the Pacific. Okay, for example, I'm Spanish. I come from the onshore wind industry, and I saw that Spain was the first country to develop a large-scale wind program. And out of that, many companies, many good companies that you now know were born. Gamesa was born out of there, Iberdrola, Acciona, EDP Renewables. And so because we were the first in Europe, we developed a lot of expertise that has helped all our companies to become important players in the renewable arena later in the world. And I think that possibility exists for Korea, and I invite everybody to try to participate there. Okay. Last, as I said before, we are a new company, Ocean Winds. Here you have my email address. Feel free to write to me if you have any questions. And of course, we have a new website which was launched yesterday, oceanwinds.com. Please visit it. Okay, so this is my presentation. I hope I made it in time. And
yes.
I don't know how it goes.
Okay,
Q&A.
thank you. Yes, thank you so much for your excellent presentation, Mr. Guzman. And before your Q&A section, I want to remind the audience again that all of you are welcome to interact with our presenters, but please raise your questions in the Q&A box. And the Q&A box is on your control panel at the bottom, and you can see it, because it will be more easier for presenters to answer and will not interrupt them. And thank you for your understanding and cooperation in advance. And then we will go for the Q&A section from the pre-collected questions for Mr. Guzman. And I think the first two ones are related to the EGPR business in South Korea and in Asia. So would you mind answering the first one? What are the criteria for EGPR to invest in Asia market?
Yeah, well, the criteria is the fundamentals, okay? An offshore project is very expensive to develop. It also takes very long time. So in order to be developing and investing a lot of money for 5, 7 to 10 years, you need very strong comfort in the fundamentals. And the fundamentals of Korea are extremely strong, okay? It is the 9th largest electricity market in the world. It is one of the countries, it has very high energy dependence. It is one of the countries in the world with more population density, okay? So we look at the details, and Korea has the strongest fundamentals, or one of the strongest fundamentals in the world, that tell us that they will need offshore wind energy, okay? And that is what gives us the comfort to start investing today in projects that we will build in many years.
So what do you think, what do you believe that you or EGPR will deliver the 1.5 gigawatt project by 2030?
Yes, that is our ambition. We still don't know the details of the project. We still don't know if it will be 80, 100, or 120 turbines. We're still working on the design. We will probably split it in phases, okay? We cannot just do 1,500 megawatt all at once. So I think that for sure we will have the first phase or the first 2 phases ready by 2030. I don't know if the entire 1.5 gigawatt will be ready by then.
Okay. And so do you think it were related to the fifth question, because the Green New Deal is just released this year, and so it has put more emphasis on the offshore wind. So how do you interrupt the recent announcement of the Green New Deal in South Korea, and what's its impact for the offshore wind?
Yes, we interpret it positively. The Korean government, I think they are aware that offshore can play a very important role in the future energy mix of the country and in solving the country's energy requirements. Especially in Korea, given the constraints that are very hard constraints in terms of population density, in terms of landscape, that make it very difficult for the country to develop onshore renewable projects. So the Korean government is making a specific decision to go to the sea to develop power infrastructure. We welcome very much that decision. It is also aligned with what we are seeing in other parts of the world, as the offshore technology is becoming more mature and reducing the cost of energy, and as the floating offshore technology is becoming a reality, many governments are incorporating bottom fixed offshore and floating offshore into their energy mix or into their plans.
Yeah, thank you. And up to now, we have received like 3 questions also from the Q&A box. Is it possible for you to open the Q&A box? Because I found one good questions from Ms. Alan Becker, and his question is that he recognized that the floating wind targets a specific part of the market, but the key to successful full-scale development or deployment of floating seems to be reducing costs. So can floating close the gap on fixed bottom?
Yes, that is an extremely good question. It is completely correct. We need to reduce costs. Otherwise, you cannot implement 10 to 13 gigawatt if the costs are not competitive. Okay, then the question, can floating close the gap on fixed bottom? There are only 60 megawatt of floating built in the world today, okay? So the industry needs to mature a lot in order to close this. But all of us who have been in the industry from many years, we have seen other renewable technologies undergo this path. We have seen photovoltaic go from 500 euro or dollar a megawatt hour to $20 a megawatt hour. We have seen onshore wind go from $150 a megawatt hour to 30. Okay, we have seen offshore very recently, a bottom fixed offshore to this path. So we have seen all the previous technologies go this impressive cost reduction track record and deliver competitive energy. Floating is still at the very early stage of this curve. Okay, we need to undergo this entire process that the other industries have already done. But I think the industry, the renewable industry is an industry of successful track record. I think onshore wind, bottom fixed offshore wind, photovoltaic have delivered this, and I am confident floating offshore wind will also do that. Okay.
And thank you so much for answering the questions and all your detailed explanations. For this part, if you still have time, you can also interact and type to answer some of the questions in the Q&A box. And now we will learn from the offshore wind, and then we will move to the onshore wind side. So let's welcome our next presenter, Mr. Andre from Peikko. Mr. Andre is working for Peikko since 2010. Due to his expert knowledge and Korean language skills, he was appointed as Peikko Korea Business Development Director from 2017, with responsibility for launching activities in the Korean market. Now he moved in the Peikko Wind application as APAC Business Development Manager. Also, on behalf of the organizing committee, I would like to express our thankfulness to Peikko sponsor for today's webinar. This supports us to continue launching free webinars regarding the South Korea renewable energy market for all the audience to join us. And really thank you. Mr. Andrew, can you please share your screen and start your presentation about the onshore wind?
Yes. Hello. 안녕하세요, 신사 여러분. Welcome to welcome to our webinars, and it's my pleasure and honor to be one of the speakers today. And I would like to share some lessons learned from our more than 10 years experience in wind activity in worldwide, onshore. In this picture on the left, on the right, you may see today one of the biggest wind projects in Europe with the Peikko foundation implemented. And however, in less than 1 and 2 years, it will be nearly standard size for onshore wind farm. In coming years, wind farm will be built up faster in the bigger scale in both dimensions: capacity per single wind turbine and the amount of wind towers per one wind farm. Also, the foundation distribution must match the fast deliveries. Some years ago, the standard foundation foundation per week was in one piece. Already now, many projects are running 2 or more foundations in a week. And we already have several sites in Europe where we deliver 3 or 5 foundations in a week. And such approach will be more and more future standard. And this gives us a new challenges to structural design, production, transport, and execution team. And according announced information in South Korea, planning to add additional almost 18 gigawatts of wind energy by 2030, meaning about 300 or 600 towers should be installed every year. And meanwhile, in 2008, total cumulative installed wind capacity in South Korea was equal to 300 megawatts in totals. And up to 2018, it reached 1.3 gigawatts, meaning that it takes 10 years in the past decade to build 1 gigawatt of wind capacity, and we will need to create additional 17 gigawatts of wind capacity in the next 9 years. So certainly, we may face a big room for improvement in both dimensions. First, wind farm permission process, and second, technical development. It looks like, can you see my next slide? I hope so, yes.
Yeah, it's still, oh yes, the next one. Yes, we can see it now.
In order to earn your trust in the Peikko expertise area and technical competence field, I would like to say a couple words about Peikko background. Peikko is mean in Finland language, it means troll, and we try to keep our troll handsome and honest. So since 1965, we become a leading global supplier for slim flow structure, wind energy applications. It means everything about onshore wind foundation design and construction and delivery components, connection technology for precast and custom and in-situ construction. Peikko innovative solution offer a faster, safer, and more efficient way to design and build. Peikko has a sales office already over 30 countries in Asia Pacific, Europe, Africa, and Middle East, and North America. And with 11 manufacturing operations around the world. I have been one first Peikko employee in South Korea back to 3 years ago, and now we have established a good and efficient team office. Peikko is a family-owned and management company that employs over almost 2,000 professionals, and we have our headquarters in Finland. We have over 30 researchers working on continuously daily basis for product development, and over 160 customer engineers and modelers working in 90 countries for our technical support. And why I'm saying that? Because to such kind of software and hardware capacity, we can provide optimized design solution and delivery style components and installation guidance for foundation for any type of wind tower, steel, precast, or hybrid type of towers for any turbine producer under different laws and project requirements located in any part of the world with almost any kind of the soil condition. Our track of record of the wind application, onshore wind application, including 10 plus years and over 100 wind farm built with our solution inside. Peikko has been provided foundation solution for the highest steel tower in the world. Together with Vestas, we built 175-meter hub-height turbine last years. Also, more than 2,000 wind foundation have our solution, have been using our solution in 60 countries in Europe, Africa, and Asia. So, before speaking about uncertainties influence to the wind project, I would like to mention about a couple specific facts. First, after study of BP, the statistical review of world energy 2019 available on the public site, I was sadly surprised that South Korea is the #5 country in the world in terms of CO2 pollution, carbon dioxide, responsible for 2.1 total CO2 emission. Please see blue chart. When I divided whole country territory by total CO2 emission volume, I got orange line showing the density of CO2 emission in South Korea is the highest in the world, about 7 tons of CO2 per area square kilometers in 2018. Of course, it's not a really scientific definition of density, but it's definitely showing needs for decarbonization of energy system in South Korea, including both wind and the solar solution. Cumulative installed wind capacity up to 2018. This diagram shows the top 10 countries in the world which have been installed wind both onshore and offshore capacity till 2018. And as you see, South Korea has only beginning on the way of implementing wind capacity in their own energy system. Another effect, levelized cost of energy of onshore wind can give us another certain conclusion that developing wind farm will grow faster and faster each year, not only because it's green or government supported or COVID safety way to energy generation, but also because it's becoming cheaper compared to conventional energy. Of course, it depends from site to site, project condition and countries, but general trend is showing that this make a reason to have investment, not only because it's environment friendly, which is extremely important currently, but because it's boost investment and economical development in the whole world, I would say. So, in order to decrease uncertainty, it's nice to and useful to use the full in-house process from one design to execution in one hand. And Peikko, that's why we have been developing 4 major processes to support this optimization. First, it's about design. We split design in 2 phases. First, preliminary design for investment evaluation stage. We are able to provide a 5 to 6% accuracy of foundation geometry and concrete steel volumes only after 4-5 days after receiving initial wind tower loading data and geotechnical reports. And with this preliminary quotation, including the cost of foundation, it's give a clear sign to investor or ERP contractor that we can provide reliable data for investment planning in the very beginning of the project. Second stage of structure design is the final design, including calculation, drawing, and specification, and third-party verification if needed. Next, manufacturing, production and delivery of steel components according of Peikko foundation design should be preferably should be in one hand because it gives us control on the whole entire project management. And project management including initial training for team installation, site supervision, and quality control during foundation installation. So Peikko wind application approach uniting one chain: structure design, production, delivery, installation guidance, and project management. And thanks to that, we can get industrial and proven production with a certified quality, fast and efficient design process, efficient and economical to produce, fast and easy to build, which is extremely important for any kind of wind farms. Time-saving site works, which is also big key drivers for and demands for decreasing the labor force involved to the project. Total economy of solution, and very important, environment friendly, that we really pay attention to decreasing CO2 emission in all our designs. If I will start to introduce shortly Peikko foundation types, we have developed till now 4 main types for onshore wind turbine foundation. 10 years ago, the main and the only wind towers foundation was a gravity foundations with a relatively simple design. Total concrete volume was on the level like 150 to 150 cubic meter, and for average turbine capacity between 1/2 and 2 megawatts. And hub height at that time was between 50 to 100 meters. Actually, you can see such scale tower as an example on the way to Incheon Airport. Now, currently developing wind farm projects require wind turbine with a 3-6 megawatts, hub height between 100 and 180 meters, and the main reason behind such size increasing of wind towers is a trend to utilizing scale effect, increase capacity and efficiency of wind turbine by installation turbine on the higher level with the higher blades. So from foundation perspective, it means that total loads are increasing dramatically and require a concrete volume per one foundation, gravity foundation around 8 or 1100 cubic meter. And in other words, it's about 80 or 100 trucks of concrete should be used for 24-hour concrete casting process, which is pretty challengeable task. And such situation give us a completely new technical challenge and limitation. That's why we are already developing 5th generation of gravity foundation design concept and developing completely new design concept as a rock, cage rock, and ribs foundation. Shortly presenting rock anchored solution, I would kindly recommend to visit our website and take a look in the video installation and presentation idea. I wouldn't launch this video right now, but you can take a look after using this link. There are two main ideas behind the rock foundation concept. First, we are utilizing load-bearing capacity of natural rock instead of making artificial stone concrete. Second, by using post-tension technology of Peikko fiber anchors grouted into 12-meter deep rock boreholes, we can utilize existing natural rock mass and load-bearing capacity in the multi-area, and they may significantly decrease concrete and steel volume required per one foundation. About 20-30 cubic meter in total per one foundation with a relatively small amount, like 3-4 tons of steel reinforcement, and about 30 to 40 post-tension front bars in the multi-area with a strong rock. And this solution provides us the smallest amount of CO2 emissions. Drawing you can see in the presentations later on, because it will be shared with everyone. Peikko steel components for rock foundation you can see in these slides as example. And I would say that 10 years ago, 5 years ago, when we started, this was like the maximum diameter was a 36 millimeter. Now we are making already 98. The reason for that is that we reduced diameter of anchors in order to reduce the amount of drill holes. Cage rock is some kind of hybrid type between rock and gravity solution, and also give pretty good performance in case of CO2 emission decreasing and saving on the concrete and steel amount. So you can see from this picture scale comparing human body with real project size. Gravity foundation is a classic design concept for wind foundation. However, it's still continuously developing due to the new loads level and design lifetime requirements. In the previous decades, sometimes structure designers were using conservative approach approach, meaning increasing total concrete steel volume by 20 and 40%, just to ensure project safety and cover a lack of calculation expertise. And it was still okay if we are talking about relatively small towers with a hub height less than 100 meters. And it's no problem to increase concrete and steel volume even for 20 or 40% from relatively low amount of concrete due to relatively small influence to the total investment cost and only small technical obstacles. However, currently, new modern large tower on the weak soil, just due to the large loads, every saved cubic meter of concrete is matter. Even 5 or 10% material optimization on 1,000 cubic meter levels is a significant, make a significant influence to whole wind farms. Reef's foundation may have a reason to be used in mega huge tower, which with hub heights that deliver to foundation over 200 meganewton of returning moment. And usually such kind of towers installed with a hub height starting from 150 meters. Main advantage, almost double reduction of concrete amount compared to the gravity foundation. However, reinforcement steel volume is almost equal, meaning that the installation work for Reef's concept could be more labor demanding. On this photo, if we use a human body as a scale point, you can get a feeling of the difference between amount of concrete required for the gravity foundation and rock foundation. At the same time, concrete reduction into if we convert concrete reduction into energy saving, just from concrete transportation into one rock foundation building site, we can save energy volume equivalent to 1 year consumption of one average Australian house with 4 inhabitants. So in this case, you can see a final study, and we designed it for 3 different solutions for one particular platform, and give us a total saving, but there is no right and bad solution. For every project with every set of particular needs, optimized solution could be different. And it's my main message that there is only one right answer for every one wind farm. We need to take a look and take a design approach in the very beginning involved in the investment cycle. And we have a lot of expertise and full cycle of expertise in our hand. And you are welcome to visit us for more detailed information, and really recommend to take a look at photo video library, which you can find from our website. Thank you for your attention. I hope I take enough time to answer your questions.
Yeah, thank you, Mr. Andrew. Thank you. Because do you remember, I still was impressed by what you said in our first talk. You said that there is actually no competition between offshore wind and onshore wind in the market because they both make the world better and there is a balance. And I think this sentence really interpreted the right energy market. And here,
yes.
Here we also have some questions from the audience for you on the screen. And so for the timing, I was more recommended to answer the first one because it is under the current situation of COVID-19. So what do you think, or when do you expect where the next commercial wind farm in Korea starting, and what is the timeline being pushed back due to the recent COVID-19 outbreak?
I would say that still it's not clear for us when we will be involved in first or next project in Korea. It's still, deadline is not fixed and not clear for myself as well in order to be announced, but I definitely see the positive influence of COVID to the wind onshore and offshore wind activity. And actually lesson learned from our worldwide experience that first investment activity in wind worldwide, thanks or independently of wind activity of COVID, is increasing due to the two reasons. First, is give a COVID energy generation safety way. What I mean is that for example, in UK, for entire 200 years of using coal as a source energy for energy system, first time in 200 years during this spring, UK was not able to use coal because it was locked down. And even we are closed in our houses, wind is still blowing and the energy is still supplying to our house. So in general, from this perspective and from an investment attractive perspective, I see the big demand for wind project in the couple of years and 10 years as well.
Okay, thank you. And so as mentioned before that, for offshore wind, there is also lots of international players. And so you can see the third question is questioning where there be demand for suppliers to source locally components in the country.
Of course, it should be cooperation because even we have a local company and we can build our own production capacity, which we are also considering. But in order to be on safe side, so for the project management, we need to have a couple sources, but still under control of one main project management company, which I think it could be us.
Yes, and now there are more and more digital players in the market to provide like digital solutions. So do you think what kind of digital solutions are you using to minimize, or were you used to minimize the risk and the uncertainty?
Yes, we are using the FM analysis and self-development softwares during our installation or design stage. Commonly, we use FM softwares as Abacus and FM, and also some integrated softwares from our side, which help us to provide preliminary design, as I mentioned, with a 5-7% accuracy in 5 days, working days, modeling done in SolidWorks, and the 3D design is help us to minimize, maximize precision and minimize collision case, which is always bottleneck for construction on site.
Okay, and besides the pre-collected questions, we also received some questions in the Q&A box for you. And I found the one from Ruben Sabanya. He asked, does this have a E certification? And because I didn't figure it correctly, and does it mean for the digital solution, E certification?
Actually, for the digital solution, I don't think it's need any certificate because anyway, you should get a third-party verification according to the local requirement in any part of the world. Regarding certification of our production, yes, we have every available possible certification in order to prove our quality of design, project management, and production.
Okay, thank you so much for your answers and your presentation. And so for the time being, we will move on to the legal side, and we'll welcome Mr. Hongjun from Maker McKenzie. And Mr. Hongjun is a New York qualified lawyer specialized in construction with more than 10-year experience. And her practice covers all aspects of construction law, ranging from the preparation of contract documents, advising on contract administration, and dispute resolution internationally. So let's move on and watch the attention to the legal perspective. Ms. Hongjun, could you please share your screen and begin your presentation?
Sure. Hold on. Well, yeah, for better interaction, I wanted to share start my video. And, you know, it's not just like me speaking, but I hope it's more like interactive conversation. My name is Ho Jang, again, and a new qualified lawyer specialized in construction and not currently with the Peikko McKenzie Tokyo office. And I'm honored to speak at this webinar, this very timely webinar, as the Korean government, as Guzman also mentioned that on July 17th, they announced the Green New Deal, and they expedite the renewable energy 3020 initiative plans further. So thank you so much for the invitation. Today, I'm going to talk about legal perspectives of wind projects. Given the limited time, these slides will cover only high-level overview of structure and the contractual risks in wind power projects. And I'll be skipping a few slides, but please feel free to email me after today's session if you have any questions or if you want to discuss. But today's agenda is briefly this.
And so finally, and most importantly, I would like to express a big thank you to our presenters today, for Mr. Guzman, for Mr. Andre, and for Ms. Hongjun. And thank you for the preparation for all the rehearsal for today's webinar and all your kind understanding to make us this wonderful show from offshore wind to onshore wind and the legal different uses. And the support to us to continue and make free and meaningful webinars. And also, I would like to express a big thank you to all the audience for still staying with us until now. This webinar recording will be released on our official website and on the public channels on this Friday. You can also find other webinar recordings about the wind or solar energy on our Leader Associates YouTube account. And last, instead of this online gathering, we would also like to meet you physically on our Green Energy Future South Korea 2020. With the impact of COVID-19, Green Energy Future South Korea 2020 has been postponed to a safer date, November the 10th to 11th. Hope everything can be settled down soon and see you on site. Thank you again for all your participation. So let's say goodbye. Goodbye, Mr. Guzman. Goodbye, Mr. Andre, and goodbye, Ms. Hongjun. Wish you all have a lovely day and a wonderful evening. And see you next time. Thank you.
Thank you.